Hello students, good morning to all. How are you all? Hope you all are fine and doing well. Now today our new topic, this is your fundamental theorem of arithmetic. Before starting this, we have take a quick review for the prime, factor and composite number. Now fundamental theorem. What is the fundamental theorem says? According to the fundamental theorem, every composite number can be written or factorized as the product of prime, and this factorization is unique. And one more thing is there, that means order in which the prime occur, it's not matter. That means it's not compulsory the order should be same. It can be vary. So we can see that composite number is equal to product of prime numbers. This can be a definition of composite number also. Okay, so we are doing one question here. In question, express 210 as a product of its prime factor. So it is very easy to you that you know how to factorize 210 as division method. Factorization method, that is 2 tens a 20 here and 2 fives a 10, then 3, it is not divisible by 2 again because the last digit is 5, so it is divisible by 3, and 35 times it is divisible. Now 5 sevens are 35 and 7 ones are 7. This is the prime factorization of 210. So we can write here 210 equal to 2 multiply 3, 2 multiply 3 multiply 5 multiply 7. This is we have written here. Or we can write is 3 multiply 2 multiply 5 multiply 7, or any other student can write it as 5 multiply 2 multiply 3 multiply 7. There are so many ways we can write it. That means in the fundamental theorem, order of the prime number, it's not the matter. Okay, the main thing is that composite number can be written as the product of prime and their factorization is unique. The unique, that means is 210. Factorization can be any other numbers? No, it is only divisible by 2. Firstly, the minimum number, that means the smaller number. Firstly, we will take the smaller number. Then we will come to another number. So first thing is that you have to keep in mind, that is you have to take the minimum number firstly. Okay. So this is, you will do the factorization and you will express. Good morning to all. Now today our next topic is HCF and LCM, highest common factor, and LCM, lowest common multiple, with the help of prime factorization method. Okay, we will find the HCF and LCM with the help of prime factorization method. So what is a HCF firstly? When you have to find HCF of any two or more than two numbers, so first thing is you will do, you will factorize the number with the help of any method, with the help of prime factorization as we have done in the earlier lecture, or you can do with the help of factor tree. Whatever you like, you can choose. So the HCF will be then product of smallest power of each common prime factor involved in the number. That means when you will factorize the numbers and you will choose that any common number which have the smallest power, that means product of smallest power of each common prime factor will be your HCF. And what about the LCM? In HCF, LCM, it will be product of greatest power of each prime. It will be product of greatest prime of each greatest power of each prime factor involved in the number with greatest highest power. We will understand this one with the help of one question. The question is, find the HCF and LCM of 12, 15 and 21 using prime factorization method. So 12, 15 and 21. You know that how to factorize 12 as with the help of prime factorization. It is divisible by 2, 2 6 then 2 3 then 3 1. So its factorizations are 2 multiply 3. We can write it 2 multiply 2 into 3. You can write as 2 into 2. How many times 2? 2 times. That means we can write it 2 power 2 into 3. Only one single 3, so with 3 power 1. It is not compulsory to write 3 power 1. You can write it only 3. When we will factorize 15, we get here 3 into 5. When we factorize 21, we get here 3 into 7. So what about the LCF? LCF was smallest power of each common prime factor. Common prime factor and the smallest power. The first thing is that it should be common, and second is smallest power. So what the number is common here? 3 with the smallest power. That means 3 power 1, 3 power 1, 3 power 1. So that means the smallest power number is your 3. So we can say that HCF of 12, 15 and 21 is 3. And LCM. In the LCM, greatest power of each prime, it should be greatest power of each prime factor involved in the number. Okay. So first thing is greatest power is 2 power 2. It should be not common. Okay. Here it is not compulsory. It should be common. So product of, because the LCM is product of the greatest power of each prime factor. Here the word is each is important here. So that means 2 power 2 and highest power of the 3 is 3 1 power 1 and highest power of 5 power 1, highest power of 7 power 1. That means the LCM will be 2 power 2, then 3, 5, multiply and 7. When we solve this, we get here 420. So as LCM of 12, 15 and 21 is your 420. Of your NCERT 1.1 question number 2nd. As 1.1 first question of finding the HCF we have done. So this is your second question of NCERT first exercise. Question is, so that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5 where q is some integers. So first thing is that we will use Euclid division lemma here for any two positive integers, that is your a and q. There exist two unique integers r, q and r, and where the r remainder is always equal to or greater than 0 and less than b, that is your divisor. So we have, suppose this one is your first equation. Here we have taken as b equal to 6 because odd integers and is the form of 6q. So we have taken as 6 as a 6q plus 1. So we have taken b as 6. Now put b equal to 6 on the first equation. We get a equal to 6q plus r. That means if we are dividing a with the help of 6, we are getting a quotient and a remainder r. That means here r is always greater or equal to 0 and less than 6. That means how many conditions are arises here? 5. Possible values of r will be 5. That means r can be 0, 1, 2, 3, 4, 5. It can be not 6. Okay. Now when first case put r equal to 0 on this. So here we will get a equal to your 6q plus 0. That means a equal to 6q. Is it divisible by 2? Yes, it is divisible by 2. It is divisible by 2. Divisible by 2. And second is your when a equal to your 1. So a will be your when r equal to your 1. So a equal to 6q plus 1. 6q plus 1. Is this one is divisible by 2? No. It is not divisible by 2. Why? Because the remainder is 1 here. That means it is not divisible by 2. Third case will be r equal to, we will put third one, that is 2. So a will be 6q plus 2. Okay, 6 cube plus 2, that means it is a even, and even remainder, that means it is divisible by 2. Divisible by 2. Same as when we are putting r equal to 3, then we will put r equal to 4, and at the last r equal to 3, and then after that we will put there r equal to 5, last condition. So put the here a equal to 6 cube plus 3, and here a equal to 6 cube plus 4, and here a equal to 6 cube plus 5. These 5 conditions are there. 6 cube plus 3, remainder is 3, not divisible. 6 cube plus 4, divisible, it is divisible. 6 cube plus 5, not divisible, with the help of 2, not divisible by 2. At the last we can see that any positive odd integer in the form of, that means in which form, any positive in the form of 6 cube plus 2 and 6 cube plus 4, it can be. Hence it can't be in the form of 6 cube plus 2, 6 cube plus 4. That means it in the form of 6 cube plus 1, 6 cube plus 3 and 6 cube plus 5. As we have to do it in this one, that means show that any positive in the form of 6 cube plus 1, 3 and 5. Here it is in the form of 6 cube plus 1, 6 cube plus 3, 6 cube plus 5. That means these are a is odd, so a can be in the form of 6 cube. Doing well at your home. Now 2 topics earlier we have completed. Now this is our third topic. The third topic is proof irrationality. You have to prove the irrationality of n numbers you have given, just like it is root 2, root 3, root 5. It can be root 15 also. It can be other than root 7, root 11. There are so many numbers. So you know that these are irrational because these can't be expressed in the form of p upon q. So, but you have to prove that so that these numbers are irrational. So how you will prove? We will prove this with the help of one question. We are doing this one. Then you will understand how you have to do other than. So we have to choose here first, that is show that root 3 is irrational. You have to prove that this is a irrational number. For proving this irrationality, we will take the method of contradiction. Method of contradiction, that means we will suppose the contradiction of this one. That means it is irrational, but we will suppose that root 3 is rational. So we have take here, we have choose that let us root 3 is rational. If root 3 is rational, that means it can be expressed in the form of p upon q. That means where p and q are co-prime and p and q are integers and q doesn't equal to 0. That means it should be completely follow the definition of the rationality, rational numbers. So root 3 equal to, we can write here a and b. We have choose here a and b numbers. A and B are co-prime. Co-prime means whose SCF is only 1. That means they have not other common factor other than 1. So root 3 is equal to A upon B. Now on squaring both sides we have done the square. Root 3 square become 3 and A upon B square become A square upon B square. Then it is on denominator, so it will goes on there. That side, the left hand side. So it become 3B square equal to A square. This is the main thing now. 3b square equal to a square. That means 3 divides a square. How? If we will do it, we can write it as 3b square equal to a square and b square equal to a square upon 3. It can be as, so a square upon 3. That means a square divisible by 3. That means a square is divisible by 3, or we can say 3 divides a square. This gives, if a square divides 3, that means a also divisible by 3. 3 divides a. So that means here 3 divides a. That means a's any multiple will be divisible by 3. That means if 4 is divisible by 2, that means multiple of 4 also divisible by 2. Just like 4, 4, 16. 4, that means it is multiple of 4. So 16 is also divisible by 2. If there is 8, multiple of 4, it is also divisible by 2. So same as we have choose here a equal to 3x, where x is n integers. Now 3x, this is your first equation. We will put the value of a here. Now we have put the values here. So it becomes 3b square equal to 3x square. Now after solving this, 3b square equal to 3 3s are 9 and x square is x square. 3 1s are 3, 3 3s are 9. And here b square equal to 3x square. Now this one, if b square equal to 3x square, that means b square is divisible by 3. If b square is divisible by 3, that means b is also divisible by 3. That means we have written it as 3 divides b. Here 3 divides a and here 3 divides b. That means they have a common factor 3. Thus 3 is the common factor of a and b. But earlier what we have supposed? We have supposed that a and b are co-prime. They have not any other factor other than 1. But here we get 3 as a factor. That means 3 is dividing a and b. So this is our contradiction. This is the contradiction. That means we have supposed, we have taken contradict that the fact that a and b have no common factor other than 1. That means this is the contradiction arise by assuming that root 3 is a rational. That means root 3 is a rational number. The real number is consists from rational numbers and the irrational number. And the rational number, you know that in the form of p upon q, these called your rational number, where p and q are your integers. So here we have take some two example here. That is, first one is a 1 by 4 and second one is a 2 upon 3. When we will divide the 1 with the help of 4, okay, we have to convert it into decimal form. So we will divide the 1, that means numerator, on with the help of their denominator. So in this case we get here the remainder is 0 and the quotient is your 0.25. That means remainder is 0. That means it is completely divisible. So we can say that this is your terminating form. When the remainder is 0, that means when the remainder is 0, it is your terminating term. Now the second one is your 2 upon 3. Second rational number is 2 upon 3. That means on the denominator it is 3 and the numerator is 2. So we will divide 2 with the help of 3. So here this one is when we have divided 2 with the help of 3. In this case we get the remainder as 2. Okay, and every time when we divide it, that means in the first step 3 6 are 18 and again remainder is 2. When again we have increased the 0 and it is 3 6 are 18 and again 2, and this process goes on. Okay, so that means in this case remainder is not 0. Remainder never become 0. So this type of term is your non-terminating term. But in this case there is one thing you are saying, that the number is here in the quotient, it is repeating. That is, every time when we divide it, it goes on 6 times. That means we can write it 2 upon 3 and it is 0.6, and on the 6 we have put the bar. The bar is representing that the number is goes on, it is not ending. In the non-terminating term, there is two case arises. The first one is when the term is repeating and recurring. Repeating and recurs both are same. That means in this case when we divide, every time we get 0.666 and it goes on up to. That means here the digit is 6 is repeating. So we will call it non-terminating and repeating terms. Now so in the rational number we conclude that in the rational number the decimal expansion is terminating or non-terminating repeating. Okay, in the rational number the decimal expansion can be terminating or non-terminating repeating. For the irrational number, we have taken, so first is your non-terminating. For the non-terminating term, when there is we have choose one number, that is your pi. Okay, so we have taken the value of pi is 22 by 7, It is not the fixed value. We have taken it as approx value. When we divide 22 with the help of 7, we get the number as 3.14159.265 and other number also. So it is not also ended here. So here no one digit is repeating. That means this term is known as non-terminating because the remainder is not 0 and there is not any term is repeating. That means non-repeating term. So this is your irrational numbers expansion. That means at the last we can see that in the rational number the decimal expansion is terminating or non-terminating repeating. But for the irrational number the decimal expansion is